All right. So I work in IBM research in Dublin, in Ireland. Excuse me for my video. Sometimes it just jams. And I'm going to present on this project that we've been working for the past 4 years called Datashim. And we started off in 2018. This was a research project that we were doing where uh, we were trying to see the scalability of training of models on GPUs. And during this exercise, we realized that using and we were using Kubernetes to deploy machine learning workloads and this training and this training workload. And during this time, we realized that the user experience of using data inside these workflows is pretty bad. And if you want to generalize the problem, this is the picture, right? So we have your typical data scientist who wants to run a workflow like a training workflow and inference workflow, and she has to look for data sets. She has to figure out where the data sets are stored, what are the credentials to access the data sets. He has to configure the jobs to use those data sets. And then you have the issue of deploying to a cluster, waiting for the jobs to turn up, and blah, blah, blah. So there's a lot of steps involved before you deploy the job onto a Kubernetes cluster. On the right side, you have the data provider who has a different set of pain points, and we're not going to talk about that. But what we wanted to have was reduce this overload of having to specify your data location uh, and do it in one single way, and that's why introducing Datashim. Datashim is a very thin shim sitting on top of CSI, and what it does is introduces a new custom resource definition CRD called Dataset, and the dataset acts as a cloud native data access abstraction. So you define the dataset once, and then down in your workloads, you can then say how many, where do you want to use the dataset, and then Datashim takes care of transmuting the pods to use the PVCs that are associated with that dataset. This project started off as dataset lifecycle framework, and then in 2020, IBM in 2021 beginning, IBM decided to donate the code to the Linux Foundation Data and AI Foundation, who took us on, and we are now an incubation project within that. And it's an open source project. We welcome all sorts of pull requests, issues. You can just start an issue, and we'll be just happy to look at it and fix them. So along with by introducing this abstraction, we figured out that it wasn't just solving the problem of being able to specify the access for a data set, but it also happened to solve a problem that we were also researching, which is how to actually manage the performance of these workflows on Kubernetes clusters. And I'll talk a little bit about the caching system that we use inside Datashim. A lot of the focus of Datashim is on S3 and cloud object storage. It's because we started out with the use case that the data sets were stored in S3 buckets or cloud object storage buckets. And turns out that that's the most popular use case for accessing data on the cloud. But nevertheless, we support other CSI plugins such as NFS and a research CSI interface called H3, and we want to support more in the future. So, of course, my video has gone off, and apologies for that. How does Datashim work in practice? In practice, the Datashim consists of an operator called the dataset operator. On the left side, you see the dataset specification. Here you specify dataset, you say what type it is, you provide the credentials for accessing this dataset, the endpoint, the bucket, and so on and so forth. And you have to do this only once. And we sort of thought that this would be done probably in advance by somebody who had the permissions to access that bucket. And then in the pod, what you would do is you would refer to this data set through a set of labels. And what the dataset operator would do is when the data set is created, it would create a PVC PV pair. It works with the CSI driver to create a persistent volume. It will create a PVC entry, and then when the pod comes in, we have a webhook that mutates the pod and inserts a PVC whenever we detect the labels. Now, if you don't want to use PVC, then we also have a mode where you can say use as config map, and the your access variables for accessing the data set would be injected into the environment variables of your pod. And if you are using it as a PVC, then the PVC will be mounted, and then you can just access it as a file system. And all of this is completely transparent to the workload. So from the workload perspective, there is a PVC, and you can access the data at a particular mount point that you can specify. So again, please go to the website. We have some examples on how to use it. We don't really have to specify the access key and secret access key every time you want to create a data set. We support a secret pair. We just happen to use this as a simple example. So the why do we want to use Datashim? Because of for example, one of the ways in which you can simplify your pipeline. So here we have a data set that has been created, and you have a PVC, and then and on the right side, what you're seeing is a kubeflow pipeline definition, and here you're using the pipeline volume, the pipeline volume feature, but you don't have to define in this pipeline where the data set is coming from. All you have to say is use this data set, which is pipeline volume my data set, and then the rest of the workflow can just refer to that volume. So it's that in one step we have eliminated the pain of having to deal with access credentials and locations and bucket location and all that stuff. It's gone. So any further volumes can just use that straight away. And we have some examples around this in the Datashim repository. Next, so you can see how we took this further, and we have an example that we worked with the European Bioinformatics Institute. I can't go deep into it right at the moment, but there's a paper for it. I'll post the paper into the Slack channel, and here we describe in detail how we took a pipeline that was a genome analysis pipeline, a query pipeline that referred a genomic data set, use different PVCs at different stages, including having different pods write to the same PVC, and we transformed this and completely changed it to use data sets. And by doing that, we not only simplified the pipeline, we also improved the throughput of this workflow. Again, I'll paste this paper into the Slack channel, but in any case, just contact me if you want more details. Now I come to the caching work that I mentioned at the beginning. And here what we did was, now instead of actually having the dataset operator talk directly to the CSI backend, we introduced a cache controller, and the cache controller would effectively talk to the operator. It would instantiate and manage a cache service, and from the CSI perspective, it's just another storage backend. And so the persistent volumes and persistent volume claims are created without any problems. And from the workload perspective, all of this happens transparently. So none of this is visible to the workload. From the workload perspective, it's just accessing a data set that is available at a particular mount point. And to prove this, we actually wrote our own cache for Cloud Object Storage, or S3. We basically forked Ceph and did some changes to it, and we did some performance testing using an analytics workload called Transaction Processing Council Decision Support that was implemented using Spark. And by doing this, we managed to basically halve the amount of time that that involved to actually execute that workload. What we could do further was that because we knew how the cache was structured, we could use the hints of the data placement in order to schedule the pods closer to the data. And by doing this, we got further improvements in performance. Again, I don't have the time to go into details, but the paper I'll post it to the Slack channel. It's linked from the main Datashim, from the GitHub repository. And please go and read it and get in touch if you want to, if you want more details about this. So where is Datashim going? Well, we are currently we are in the process of changing its operator dependencies and bringing it to Kubernetes 1.22 plus. But we want to introduce ephemeral volume support for S3, which is not done at all. We want to integrate with COSI when COSI is finalized and ready for doing that. We've been working with the COSI team, or one of our members has been working with the COSI group last year on the specification. We want to improve our support for CSI plugins by having auto discovery capabilities. We want to support a lot more frameworks. So right now we have examples with Spark, Kubeflow. We want to support Tecton, Flight, and we want to actually go and explore more about how to actually get visibility into the usage of datasets, and can we leverage that information to do something further with improving the availability and the performance of dataset access. So with that done, I would like to acknowledge all the people who have contributed to Dataset. I'm right now the primary maintainer, but Datashim was started by Yanis and Christian 3 years ago. They've moved on to other interesting projects. Panos was instrumental in carrying the project forward, and he also implemented the cache plugin that I just spoke about. And there are lots of other contributors from different companies who have found niggles and who have found annoyances that they wanted to be fixed, and these have all helped improve the project immensely. So thanks to all of that, and with that I come to the end of my talk. But
okay,
if you have time, I can actually show a short demo. But
yeah, if you think you can squeeze it in, go for it.
Okay, so let me see.
All right,
new share. This is going to be a live demo, so Murphy's law, I hope, doesn't come into practice.
It's all good.
So all right, so I have actually created a secret pair. This is all running, of course, on my and this if you can see my screen, this is the secret that contains the access key and secret access key pair. Now what I have is an example data set which just accesses a bucket using this secret key pair at this endpoint. So I'm going to create that. Sorry. And now what I get from this is a data set called test, and this should have generated the PVC pair and the persistent volume, and it uses CSI S3 because it's using S3 backend. And now I have a pod definition that uses this data set, which is here. Again, here, what I've done, I was testing something, so I actually turned off the labels, but you could actually access the data set directly because the name of the persistent, the PVC is the same as of the data set. So you could basically use it directly here and then mount it under whatever mount path you want to use. So if I were to create this pod, as I said, if I had just left the labels and not specified the volumes, this would still work. But for the sake of time, I'm just going to. So this is an Nginx pod. It's creating. I should have probably gone for a smaller image. It's running good. And if I actually describe this pod, you can see that it's mounted the data set in that mount point. And if I want to do an exec inside the pod, uh, I hope you can see this. I can actually go to the mount point and access the contents of the bucket that was there on my on that location in Cloud Object Storage. We are using IBM Cloud Object Storage in this case. So with that, I'm come to the end of my talk. As again, please visit the repository or ask a question to me by email. Thank you very much for your time.